what Bricklayer.org wants to do is help put a dent in this problem, right? Contribute to the solution of this problem. And so what is Bricklayer? Oh, thank you very much. All right. Cool. Thank you. So Bricklayer is a set of apps, online tutorials, curriculum, and documentation. So it's an ecosystem. And the goal of this ecosystem is to encourage and facilitate teaching mathematical thinking, computational thinking, in a way that uses visual arts. So you write programs that build things. And so here's some examples of things that have been built. In Bricklayer, Bricklayer can connect with Lego Digital Designer. It can connect with Minecraft. It can connect with 3D printers. And Arduino is one of the things that we're working with as well. So there's some 3D printed stuff over there that my son Aiden has. You want to hold something up, Aiden? That's, there's a Menger sponge printed. This was printed at the Do Space. Aiden coded one of those. Okay. All right. So one of the things that Bricklayer is, so it's this tool that lets you, it's this system that lets you do this, explore this kind of stuff. Oh, thank you. But Bricklayer is also by design, it's a low threshold, infinite ceiling system. And what that means is that our goal is to make it easy to get started using Bricklayer. That's the low threshold part. But Bricklayer programs are also written in a functional programming language, a fully general purpose one, which means that the sky's the limit. Anything that can be computed ultimately can be computed in the general purpose programming language, which Bricklayer is. So that's the infinite ceiling part. So you will find stuff to keep yourself challenged, just like with art. In art, if you give people a paintbrush and some paper and tell them to draw a person, somebody will draw a smiley face and the other person will draw a portrait. Same thing, right? This is the power of art. And so again, the goal is we want to have, for us it's about thinking, it's about engaging, it's about creativity. And so to us, they're all intimately linked, and it's all about patterns. So it's about seeing patterns, it's about understanding patterns, about creating patterns. That's when you leverage the machine to create art for you. So a couple of highlights about Bricklayer where it currently is. It's been used in about 80 schools in eastern Nebraska, mostly in gifted programs and mostly in elementary schools. But it has also been used in a couple of middle schools and in Bryan High School, for example. And the Jesuit Virtual Learning Academy wants to do an online Bricklayer program sometime next year. That would be nationwide, maybe even international. Nebraska City's highlighted because Kate Sherwin is in the audience and she's going to lead you through some Bricklayer related exercises. I want to say a couple more things. We have done we've at the preliminary stages of doing some pre and post tests as to does Bricklayer help you with your spatial abilities, or what kind of skills do you learn beyond learning how to code, which is incredibly important in its own right. But from a mathematical perspective, we have been able to show that there's a significant gains in spatial reasoning abilities and in coordinate graphing systems with the pre and post test that we did with 4th and 5th graders. And the person who did all of that analysis is sitting back there, Michelle Friend. She's also part of the Bricklayer UNO team, though I guess we're technically called the Mathematical and Computational Thinking Group. This is the newspaper at Bryan High. And so they did an article on this Bricklayer class, and so it's been a lot of fun. Kids are doing really cool things out there. And Charlie Cuddy is the guy that's teaching this class, and he was awarded a Do Space Fellowship last summer, and he coded up, among other things, he coded up the Memorial Stadium in Bricklayer. So this is online. You can go to the Bricklayer Minecraft server and actually go inside this stadium. Yeah, 350,000 pieces. All right, so I want to, there's a document that we're going to hand out to everybody. We'll make this stuff available online as well, and I'll show you where we'll put it. But I just want to talk a little bit about circles and what the potential is mathematically for some of these things and artistically and so on. So here's this a fun exercise that's easy to get started with is, okay, you know a function call for creating a circle of a certain color, at a certain location, of a certain size. Now just freeform. Do drops of paint on the floor, right? Make something that looks any way you like. And what ends up happening in something like this is you place a couple of circles randomly, and then all of a sudden, as you progress, you develop an opinion. Like, I think this next circle needs to be over here, needs to be a little smaller. It needs to be halfway inside this circle and halfway outside. And you can't help yourself. I mean, when I do it, it's just, I mean, we haven't studied this, but I feel like you can't help yourself. You want to move these things around. And so to do that, you have to understand spatially how these things fit together, where they're placed. You have to understand radius, if you want one circle to fall inside the other one or fall outside or halfway. So there's a bunch of interesting thinking that takes place just by doing that, and it's pretty accessible. It's pretty easy to get a group to do this. But I do want to point out just a couple of math standards and stuff and art standards that this would hit, right? So if you look at this math standards, this is 4 through 8 means 4th grade through 8th grade. Coordinate geometry, students will determine location, orientation, and relationships on the coordinate plane. Okay, I think it hits that one. Math standards 8, this is 8th grade, perform and describe positions and orientation of shapes under single transformations, including translations, dilations, bigger and smaller, on and off the coordinate plane. You can have circles halfway outside. So I would argue, and I'd love to sit down with math people and flesh this out too, right? So, and then the art standards, I think it's pretty easy to hit a lot of these, because you talk about interpretation, you talk about mood, you talk about use of color and stuff like this. I'm not going to read through these, but I did want to put them here, and these slides will be available. I did want to put them here so you could kind of use of patterns, symmetry, shape, balance, themes, styles, and principles. There's a lot of stuff that this hits. Personal interpretation, message, effects, all of this stuff. So here's another one, the Olympic rings. Okay, these are not interlocking the way the Olympic rings are supposed to be, but if you were going to create this with rings, well, you have they need to sort of fit together in some way, so there's a little bit of math that goes on there, a little bit of calculating. And but if I said, well, can you make those, now that you've created this, can you modify your program so that the rings are bigger? They say like, well, if I had to do that, I might have to move them all and recalculate everything. And go like, yeah, that's right. Unless you knew a couple of other things, and then you could write a formula that captures the spatial relationships of these rings relative to the size of the radius. So depending on how far you want to push this and where your audience is at, you can make this more challenging or less challenging. You want, for example, the space between the rings to remain fixed. And how would you capture it if it's not? Is it proportional? Right? So you can, it's sort of, the sky's the limit a little bit on this as to how creative you want to get on pushing this. Here's another one. I want these 5 rings that have the same radius positioned, and I'm giving you some hints. There's a diagonal line connecting the centers, this X. And so where's that center, the middle one, the yellow circle, where's that, what's that coordinate relative to, let's say, the lower left, the pink circle? So this is the Pythagorean theorem, right? So you know the hypotenuse of this. Of course, now you could do this by trial and error too. So there's a brain versus brawn thing that's happening here as well, right? And so the document that we've handed out has sort of a bunch of these kinds of examples. That's just the rings part and circles. And also, like with the Olympic rings, I'd like to point out that they have cultural significance. So if you want to get into this art stuff, right? So you really can emphasize different things here depending on what your interests are and where you're trying to go with stuff. And so what I'd like to do now is have everybody turn on their machines and let's do some hands-on stuff. So if you open up a browser, a Chrome browser is preferred, but other ones can work for at least what we're doing. If you open up a browser and you type in bricklayer.org.
If anyone didn't bring a computer, don't we have?
Yes, we have computers in the back if you don't have one. The network, yeah, there's a student, there's a UNO unsecured that you should be able to get at. And we have helpers running around, so if you have any problems with anything, just raise your hand and we'll come around and help. Chrome is the preferred one. But for what we're doing today, I think any browser would work. You good? So on the dissemination page, here's where I'm going to put a link. We're going to record this video and stuff, and we'll put it up here with these documents and stuff. So if you want to go later or share it with a friend, you can go to this place, the dissemination page. This is where we have the virtual tour. A YouTuber that does football stadiums did Charlie's Stadium and did a really cool version of it that he put on YouTube. And we have some some conference papers and stuff, and so we'll put it under here under presentations. Bricklayer, the website, there is some stuff for teachers here. There's some sample curriculums, little short ones and stuff. There is if you're a student, if you want to learn Bricklayer, this is the tab that you go to. There's a bunch of stuff. It starts with some unplugged stuff where you study patterns and stuff and so on. In the interest of time, we will kind of I'll just say a couple of words about this. And this is sort of like karate where each level gets kind of harder. And there are tools that we have here, web apps and downloadable software that's in the apps column and in this tab, including software that you can download for Windows and for Mac. It's all free, everything's free. We're going to, there's Bricklayer Lite, which Kate is going to have you do some coding on in a little bit. And then there's Truvia, which kind of gets you started speaking coding language. So let me get you started on Truvia. So if you go to Truvia, there's some stuff a bunch of documentation, but let's just jump right into exercises. And so the objective of Truvia is if you think about building artifacts that are block-based in discrete spaces, like Lego, you have this Lego base plate, you have this idea of I want to place a brick of a certain size and a certain shape at a certain location. So we have to kind of agree how to communicate that kind of information. So we need to talk about coordinates, we need to talk about brick shapes and so on. And so this helps you do this by starting you out very gently. We start at the beginning by saying, let's just figure out stuff about coordinates. So you have this, I can turn on coordinates on and off. The good rule of thumb is you run before you jump. So if I give you two numbers, the first number is across, the second number is up. And so this assignment here says, put a 1x1 green brick in the cells whose locations are, and then it gives you a bunch of locations. So I'm going to scroll down here. And so I will take this stuff here and make this a little quieter. I've done this before, so I wasn't just solving this problem for the first time, if you were wondering why I did it so fast. But once I think I have it, I submit, and if I have it right, I get the fireworks. And if I have it wrong, I can try again, or it can show me the answer. So I can always see the answer. So let's say I submit something and it's wrong. So I could try again, or show me the solution. Whoops, try this again. Whoops, I'm on the wrong problem now. Yeah, so I'm on this one. So this would be the solution for the second one.
One of the really cool things about the Truvia is if you make a mistake, you can go back and try it again. It's not like a right or wrong process.
And so this is a self-paced app, right? So you can interact with this, you can learn at your own pace. I just recently connected this to a YouTube video. So the goal eventually is to have each one of these concepts have a YouTube video that explains how these, what the purpose of the concept is. Anyway, so this is, and they're short videos. This is like 5 minutes or something. But anyway, so what we can do is we'll do a couple of these concepts, a couple of these exercises, and then if you go to concept two introduces the idea of variables. So rather than have absolute positions, you'd say, if you let xz be a certain location, what is x plus 2 or z plus 2? What do coordinates like that mean? I don't have a video for that one yet, as you can see. After that, when we get to concept 3, it says, okay, let's talk about having sentences. So now you understand coordinates. So I'm going to turn this into English sentences, and the sentences are things like, put a 2x2 red brick at location 3-2. So now we have to confront the idea of what happens if there's a brick. Well, first of all, what does a 2x2 mean? So 2 wide and 2 tall. And what does it mean to put it in a single cell? So then we have to come up with this convention of, well, we'll decide by convention that it's the lower left corner that goes at this location, 3-2. So this is a red brick, 3-2. Did I do that right? Do we feel good? Anybody? We'll submit. And so now if we have a 4x2 yellow brick, what does that mean? So is the first dimension going across, or is the first dimension going up? Is it 4x2 or is it 4x2? And so, by convention, we decide that it's across first. That would align more with how we do our coordinates. But so by the time we're done with concept 3, we are pretty good at these sentences. And then concept 4 just sort of starts stringing these sentences together. So at this point, if I give you a Lego base plate and a bucket of bricks, I should be able to write a note in English to you and hand you that note and have you build what I was thinking of. So you are the computer and I am the programmer, and I'm programming in natural language. So now the next thing that I need to do is, well, if I could take this English sentence and kind of distill it into its essence, a name. That name could be a function. So I'm going to say the shape of the brick is important, 2x1, the color is important, blue, and the action is important, put. So we have this name, so this is this mnemonic device that helps us remember what these functions, what kind of functions there are possible. And this function takes as an input the coordinate. So now you have translated this English sentence into a function call, and this is programming now. Right? So at this point, you can write this in a Bricklayer program and it would place this for you. So now now you're talking to the computer. And then from this point on, we take sequences of these. So now you have a little bit more complex programs. And then from there, it just keeps going. Right? But you get some sense of the gradual steps that are involved. So each one of these steps is fairly manageable. And you have these tools that you can interact with, and there's other tools that I haven't shown you either yet, just in the interest of time, we're only going to do this. But what I would like to do now is turn over the floor to Kate, and she will take it from here.